So our lecture today is going to involve algorithms, and I'm going to define them, talk about some of their characteristics, and then I'm going to produce a algorithm based upon an example, and we're going to use a cooking algorithm. Obviously, that's what's up on the screen here, but I'll produce an algorithm using a natural language. Okay, so algorithms, definition: it's a precise, systematic method for producing a specified result. And we find algorithms all over the place. For instance, directions. If I give directions how to get from this location to the other, that can be construed as an algorithm. If I am giving a recipe to cook something, that can be interpreted as an algorithm. If I'm assembling something, there's usually some diagrams. That could be considered an algorithm. All right. So algorithms, really, I'll say that you'll see them in three different forms. Okay. One, you'll see them written in natural language. That'd be like a set of instructions. Okay. Two, you'll see them represented graphically. All right. So we might have a diagram for putting together something. I'm going to go into another detailed little demonstration here where we look at creating a flow chart, which is another way of representing an algorithm. Okay, and then three, we put together an algorithm in some sort of, and we'll call it programming language. And we'll be doing a little more of this in our next unit when we actually write some code. But if we have a formal language rather than a natural language like English or Spanish, a formal language like Visual Basic or JavaScript, those give us a more precise way of describing exactly what we want to take place. All right. There's 5 essential properties of algorithms. Make sure you read through this in your text. There's input, there's output. There's also definitiveness, effectiveness, and finiteness. And I'd like to become familiar with those. All right. Well, let's complete our example here. And I got 2 documents up here. One, and I'll post this up in your Moodle shell here. But this is the format I'd like you to use for your algorithm. First, give it a name. Okay, what's the algorithm for? Secondly, what input do you need? Thirdly, what output is it going to give back? And then lastly, here's the instructions to execute it. All right. So I have here as an example, I have some instructions for cooking, and this one I pulled off the web here is really nice because it's got all these great little graphics on it. All right, but really to cook or to bake a cake here in this particular instance, you heat the oven to a certain temperature, you get all the ingredients, you mix them up, you pour it into a baking pan, you bake in the oven, and then there's right here is something known as a conditional. We check the cake. Is it cake done? Well, if it doesn't spring back when we touch the center of it, then it's not done. So we repeat by baking for 5 more minutes, and depending upon whatever external factors are out there, we'll continue to repeat that process until the cake's done. When it's done, we'll put it on a cooling rack and then we'll cut it and enjoy, right? Okay, so let's write that as an algorithm. So think about, well, first let's go ahead and document the algorithm. Okay, so this is, of course, I'm not very specific here, but I'll just say baking a cake, and I'd be probably more specific if this was a real recipe. So my input's going to be, well, what do I need? What are my ingredients? Okay, so my input, things I'm going to need to do this, I'm going to need flour, butter, sugar, milk, and eggs. All right, I'm also probably going to need to get out a mixing bowl, maybe a spoon, and then I need a cake pan, and maybe this particular recipe calls it 10 by 12 inch cake pan. Okay, very specific here as far as what I need for input. I'll need an oven there too. I guess I could put that in there. I'm not gonna output. We're all done. What we're gonna have? We're gonna have a cake. All right, and let's put some instructions together. All right, and let me go back over here. All right, so instructions again: preheat the oven, mix all ingredients together, pour them in a pan, bake in the oven, and then go through this little loop here until the cake is done. And then when we're done, we're going to put on a cooling rack and cut it open. Okay? So first, preheat oven. And it's very precise, 350 degrees. Okay? Gather and mix ingredients in a bowl. what's next in my algorithm here? Pour the mixture into a cake pan. Okay, next, bake cake for 30 minutes. Okay, now comes our condition here. And I'll start out by using the word repeat. Repeat. Actually, the first thing we want to do is we want to check to see if cake bounces back. Okay, and we're going to kind of leave it at that. That's maybe a little less than descriptive. And then if it doesn't, what are you going to do? Bake for 5 more minutes. Okay? Alright, so we check our cake, and if it's not done, we're going to bake it for 5 more minutes. And then once it is done, we're going to cool on the rack for, I don't know, let's say 20 minutes. And lastly, we're going to cut and serve. All right, fairly simple. Here's a short example on how to create an algorithm.